Second problem. In problems, a rope of negligible mass is wound around a hollow cylinder of mass 3 kg and radius 40 centimeters. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 newtons? What is the linear acceleration of the rope? Assume that there is no slipping. Okay, a rope of a negligible mass is wound around a hollow cylinder of mass 3 kg. Here we have the hollow cylinder like this. This is our hollow cylinder. Okay, so then one rope is wounded. Okay, so one rope is wounded like this. Okay, then we apply so the radius of the what is the angular acceleration of the cylinder if the rope is pulled with a force of 30 newtons? Now we pulled this rope with force that is 30 newtons, and mass of the cylinder is given. Mass of the cylinder is 5 kg. Okay, so then radius of the cylinder, not 5 kg, it is 3 kg. Mass of cylinder is 3 kg and radius r is also given, that is equal to 40 centimeters. 40 centimeters, and that is equal to 40 into 10 to the power of minus 2. Okay, so this is equal to 0.4 meters. Okay, so then force equal to also given, that is force is equal to 30 newtons. Then after applying this 30 newtons of force like this, and the axis passing through the cylinder is like this. Okay, so this is our axis, hollow cylinder. Okay, so this is axis, and about this axis, when we are applying this force, it is rotating like this. Then when it is rotating like this, it is having some angular velocity, and the change in angular velocity is nothing but angular acceleration. Now we have to find out that angular acceleration. Okay, so for that, here there is not provided angular velocity, so we have to use the one formula, that is tau is equal to I alpha. This is the Newton's second law in rotational motion. So from that we have to take this, we have to find out the tau and also moment of inertia of that hollow cylinder about axis. Then we can find out the alpha. So here we are applying this force here F, and the radius of this cylinder is R. So then it is tau is equal to, so we know that tau is equal to F into R. Okay, so the tau is equal to F into R. Okay, so the radius is here R. Okay, then force is here 30 newtons. So this is 30 into radius is 0.4, and this is equal to 101 point cancel 3 4 12 Newton meter. Okay, like that, moment of inertia moment of inertia of cylinder about axis. It is a hollow cylinder. For that, moment of inertia I is equal to mr square. This is our we have a tabular form in the textbook, you can see that there. Okay, from that I is equal to m, mass of the cylinder is 3 kg and radius is, that is 0.4 meter square. and it is equal to 3 into 0.4 square means it is 0.16 and it is equal to 0.48 kg meter square. Now we got this I and also tau. Then from that we can calculate the alpha. From tau is equal to I alpha, then alpha is equal to tau by I, and the tau is equal to here 12 by this alpha is equal to I is equal to 0.48. Then it is equal to, that is alpha is equal to 1200 by 48. If you are removing this point, then 2 zeros in numerator. Then it is equal to 12 ones and 12 fours. Okay, so that is equal to alpha is equal to 100 by 4 and alpha is equal to 25. The 4 ones are, this is 4 25. So 25 alpha means radians per second square. This is our angular acceleration. Then linear acceleration. Linear acceleration, that is A is equal to R into alpha. Relation between angular acceleration and linear acceleration. From that A is equal to R. R is equal to 0.4 into alpha is equal to 25, and this is equal to 10 meter per 10 meter per second square. This is linear acceleration and it is angular acceleration.